Hello everyone. We're going to be going through some applications of quadratic functions today. Some situations in the real world offer problems that involve quadratic equations. While these may be solved algebraically or graphically, usually it's easier to solve them using a graphing calculator. So we're just going to go through one example. Astronauts working on a space station toss a ball into the air. The height of the ball is represented by the equation y equals negative 2.7x squared plus 13.5x plus 14, where x represents the number of seconds since the ball was thrown and y is the height of the ball in feet. So there's two parts here. We're going to do the first part A, and then we're going to discuss part B. So to the nearest hundredth of a second, what time does the ball hit the ground? So if you're looking at just a sketch of this function, it's going to look something like this. So there's your axes. It's going to go up and it's going to come down. And if you graph it in a graphing calculator, it'll look something like that. There are two zeros here that we need to find because we want to find when does the ball hit the ground. So there's a couple ways you can do this. We're looking at the equation y equals negative 2.7 x squared plus 13.5x plus 14. So when you're solving quadratic functions like this, you have choices. You can try and factor it. If you'd like to do that, be my guest, but I am not going to do that way because this has decimals in it, and decimals are scary when you're trying to factor. You could try completing the square. Again, if you want to try that, you are more than welcome to, but this has decimals, and we are trying to take halves of things and then squaring them. It does get a little confusing, so we are not going to do that either. We are going to use the quadratic formula. That's what I'm going to do anyways. So I'm going to ask myself first, what is A, what is B, and what is C? So A in this case is negative 2.7, B is 13.5, and C is going to be 14. I'm going to plug it into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this turns out to be x equals negative 13.5 plus or minus the square root of 13.5 squared minus 4 times negative 2.7 times 14 all over 2 times negative 2.7. When you plug this into your calculator, and I'm actually going to change to a different board here, just so we have a little more room. So we're going to move back up to the top here. So when you plug that into your calculator, you'll end up with x equals negative 13.5 plus or minus. When you plug all that stuff under the square root in there, you end up with 333.45 all over negative 5.4. This is where you want to split into a positive and into a negative. So when you do negative 13.5 plus, you'll end up with x equals something like negative 0.88159506. And I know that you don't have calculators, that's perfectly fine. When you round it, it ends up being x is about negative 0.88. When you do the minus side of it, you end up with x equals something like 5.881595, or 5.88. Now, it's asking when the ball hits the ground. You cannot have negative time, so we're going to have to go ahead and reject the negative answer. So after about 5.88 seconds, the ball hits the ground. The next part B, says to the nearest tenth of a foot, what is the greatest height the ball achieves? So if you're looking back down here at this, it's asking you, when is the ball at the highest point here? And you can actually use a graphing calculator to do that. I'm going to give you the steps for it, and the first thing you should do when you come into class tomorrow is plug this into a calculator, follow the steps, and see what you get. So, the first thing you want to do is, in your calculator, you want to graph the function, which is in this case y equals negative 2.7 x squared plus 13.5x plus 14. The next thing you want to do after that, and you should definitely write these steps in your notes so you have them tomorrow, is you want to push the second button, and then you want to push the trace button. Because up above that it says calculate or calc. Depending on the function, you want to either pick, we're looking for the maximum, which is what we're looking for in this case, or you'll notice there's a minimum there. And there are some problems where you're looking for the minimum, but in this case you want to pick maximum. Once you do that, it'll take you to your graph and you'll see a little asterisk on there. You want to make a mark to the left, then make a mark to the right, because you have to give the calculator some area that it's looking at. So on your graph, whatever it looks like, we know that the maximum is in here somewhere. So you need to put a mark somewhere on this side and somewhere on this side. It has to be kind of close, but not super close, so that the calculator knows, okay, I'm looking from here to here, and it's in there somewhere. And then the last thing you want to do is push enter for answer. So I know most of you don't have graphing calculators at home. So when you come into class tomorrow, the very first thing I want you to do is put this into the calculator and see if you can figure out where the maximum is and what it is. Have a wonderful night. I will see you tomorrow.